variables within JavaScript, everything you need to know, plus one of the most kind of tricky things when it comes to the const variable. So first things first, what is a variable within JavaScript? So a variable within JavaScript or within any programming language is going to be some label or some name for a value within your program. And this allows you to reuse that name throughout your program to reference that value. So these variables or these names or these labels will point to certain values that are stored in memory for your program, and then you can use these values throughout your program by just using that label or using the name of your variable. So in JavaScript, we actually have 3 different ways to declare our variables. And in some programming languages like Python, you actually don't need to declare a variable. Python just knows that if you use a certain name and assign it, use the assignment operator, which I'll get to in a second, that it will automatically create that variable. But in JavaScript, you do have to use a variable declaration. And you can use either var, let, or const. Those are the 3 different types of labels that you can use for your values in JavaScript. All right, so first things first, let me just show you how you might create a var declaration. So here you would use the keyword var, and then you would use some human readable label for the value that you're going to use. So I'm going to be not very creative here. I'm just going to call it some value. And then the equal sign here, the single equal sign, is an assignment operator. This is not a comparison operator. You're not asking your program whether some value equals some other value. That would be either double equals or triple equals, which I also have videos on. But here you're using the single equal sign, which is the assignment operator. And then here on the right-hand side of the assignment operator, you can assign this label, some value, to a value. So now, if I reference this label within my program, it will evaluate to this value here, code Ryan. So if I console log some value, and then I run my program here, you see that it evaluates to code Ryan. And make sure that you say hi to Ragnar, my German Shepherd, in the background there. But the label will evaluate to whatever value that you assign it to, the value that is to the right-hand side of the single equal sign assignment operator. Okay? And this is how you create a var variable within your program. You're just assigning this label to this value, and then you can reuse this value or this label to evaluate to this value throughout your program. And it makes things much more reusable. It makes things much more human readable. And it's a good idea to use very descriptive labels and variables within your program. So a better name for this label here would be YouTube channel name, as my YouTube channel's name is Code Ryan. So a good representation for that, a good human readable representation for that to make our programs easier to reason about, and a good label to reuse this value throughout my program is YouTube channel name. All right, because that represents the value that it's pointing to or that we assign to it with this single equal sign. And this works for all of our variable declarations. To declare a let variable, you just do let YouTube channel equal code Ryan. You see I get code Ryan. So it's still going to evaluate to it. And then with const, it's the same thing. It's either the var, let, or const keyword here, the label you want to use, and then equal sign, the assignment operator, to whatever value you want to assign to the label. And then you can reference that label throughout your program to reuse that value or to evaluate to that value you assigned it to. So if I run this one here, you see that all of them are going to evaluate to code Ryan. Okay, now you might be thinking, okay, well, why does JavaScript have 3 different ways to declare a variable if they all evaluate to the same thing? Well, each one of these variables has some distinct characteristics that potentially make them better or worse depending on your use case. So let me dive into the attributes of the var variable here, okay? And I will dive into all of these in a little bit more depth here, but overall, var is function scoped, and scope is at any given line of code, what variables or what values do you have access to? Check out my video on scope for more kind of detail there, but it is function scoped, it is reassignable, it hoists as undefined within the parse phase of JavaScript, and this isn't necessarily specific to a var declaration, but in JavaScript, if you're not in use strict mode, you're not in strict mode in your program, then if you assign a value to a label, then automatically in your global scope, you're going to create a variable within your global scope. I will go over that in a little bit more detail here. So the first example here is over function scope and the var keyword. So if I uncomment lines 9 through 20 here, you're going to see that, okay, in this function, we have the var with the label first, and we assign it the value of first. And then we console log out first. And then here in the second function, we use the label first again, and we assign it to a different value, and then we console it out. And then here we run both functions. Putting the parentheses on the name of a function, we'll call those functions, and it will run these two functions here. I will create separate videos on functions here, but for example purposes, I am just running these functions down below. So when I do this, you see that both of these variables with the same name evaluate to different values. And that's because each one of these functions has a different scope, meaning this function here isn't accessing this variable here, and vice versa. This function here is not accessing this variable here. It's accessing the var declaration within its scope, within the function scope. Okay? So let's continue from there. And var, kind of the second part of this, is it's reassignable. So let me uncomment these out here. So you can see I am creating the label whatever in my var declaration, and I'm assigning it the string whatever, and then I'm console logging it. And then I say whatever is equal to what. So I am reassigning a value to this label that I already declared here. And then I console log this value again. And in JavaScript, it is a single-threaded synchronous language. You can do asynchronous things, but by default here, it's going to synchronously, line by line, evaluate each line of code in order from top to bottom. That is sometimes referred to as the thread of execution. The thread of execution is going to go down line by line and evaluate each line of code. So here, if I run, and let me clear my console there, you can see that this program compiles, it runs, and I first log whatever here with the value of whatever, and then I log it out again, and it has the value of what. And that is because var variables or var declarations, you can reassign that value. So this is a reassignment occurring here on line 11, assigning the label whatever to the value of what. And then that is totally doable with a var declaration. Now, one interesting thing here as well is that var hoists as undefined. And this is commonly thought of that JavaScript will put the var declaration at the top of your program. It doesn't necessarily do that. JavaScript has what can be thought of as a parse phase before it actually executes your program line by line. It will go through a phase in which it basically runs through your program quick, and it's like, hey, what are my different variables? What are my different function declarations? What are my certain scopes throughout my program? So it does that first kind of little parse phase, and then it will execute your program line by line. So it is kind of a two-pass system. So with that, when it goes through its first pass here, if it sees a var declaration, it will actually kind of say, hey, we have a var declaration here. Let's assign it to the value of undefined right now. And then when we go execute the program, we are then going to assign it the value with the assignment operator. But since var declarations, they allow for this behavior of hoisting, you can actually reference them before the assignment actually takes place. So on line 9 here, I can actually reference this hoisted label. So on line 11, I'm creating the label hoisted, a var declaration, and assigning it the value of some value. I can reference this on line 9. Because in that initial parse phase, JavaScript will see, hey, we're actually going to have a variable declaration here of hoisted. We're not going to assign it a value yet, but we are just going to give it undefined. We're like getting it ready. So to prove that, I'm telling you correct things, you're going to see that hoisted logs out to undefined. And when I do my console.logs, I often like to console log them within an object here. So I'm actually creating an object. And in JavaScript shorthand properties, I'm actually creating a property here, hoisted, and assigning it to the value of hoisted. We'll go over this in much more detail in future videos. But the reason I like doing that is because when I console log it, it gives me kind of the label name and the value. So the label name here is hoisted, as you can see, and then the value here is undefined. So this is kind of showing that you can reference a var declaration before you actually assign it a value. And then if I log out hoisted here again, you're going to see that, okay, when I reference it before I have the assignment on line 11, I get undefined. And then if I reference it after the assignment, I get the value as we would expect. So that is hoisting. And the only variable that does that is a var declaration. Now, function declarations will hoist as well, but we will talk about those when I go into functions in more depth, all right? But that is kind of, you'll probably hear the idea of hoisting quite a bit in JavaScript, and it's effectively that first kind of parse phase in which it will initialize those var declarations and function declarations. In the case of var declarations, it will hoist those to undefined. Now, I mentioned kind of non-strict mode earlier, and as you can see on this line here, I just say non-strict is assigned to the string value of oh no. Right here, I am not actually giving this a var declaration. I didn't use the var keyword. But in non-strict mode, JavaScript is actually going to be like, okay, so you probably just wanted to make this a global variable. Let's actually allow that to take place. So this program compiles and it runs. This is generally not a great idea, as in your programs, you probably don't want to just like auto-generate global variables, as that can cause it can make your programs a lot more difficult to reason about if you have a bunch of global variables. And it can also lead to different naming collisions if you have a bunch of global variables that you're not aware of, and it can just lead to bugs. So here at the very top of a file, you can add a string, use strict. Did I spell that correctly? I did. And then you can see I actually get an error here. It says non-strict is not defined, because in strict mode, it prevents this auto generation of global variables within your program. All right. And you normally, if you're using something like React or some framework in JavaScript and in a professional level application, it is often given to you automatically, and you don't really need to manually do that, but it's something to be aware of. Like if you're getting a bunch of weird behavior like this, you might need to check and make sure that you are indeed in strict mode. So that is the var keyword. Now let's move on to let. So let is block scoped. So it's not function scoped. It is block scoped. It is also reassignable, just like the var keyword, but it does not hoist. Well, it doesn't effectively hoist. You can't reference this label before assigning a value. It will not evaluate to undefined. And here I just add a little note. It's still seen in the parse phase, like in that initial pass, it'll still see these kind of let declarations, but it just won't let you access it without throwing an error. Okay, so I'll go over that just like I did for the var keyword. So first off, let's talk about block scoped. So as we can see here, I declare a let label with some value and I assign it to the value of some value. And then I create this block here. So a block is anything within curly braces. And this also means that even if this wasn't a while loop here, it could just be curly braces and this will work the same. It will create its own scope. While loops, for loops, an if statement, anything within the curly braces is going to create its own block, and that's going to have its own scope. And let variables as well as const are going to have this block scope. In the outer scope, you can see I do this assignment of some value to some value, and then within this while true loop, I set let some value, so the same name, is equal to some other value. And then I console log the inner value here, and then I console log the outer value outside of this loop. And this break statement is just going to make sure that I only run this loop once and don't blow up my program. So here you can see the inner value. So this is going to go line by line. It's going to go, okay, while is this condition true? Well, it's just the value of true. So while true, it's going to go in here. It's going to create this let declaration and it's going to console log it out. Now, if this was a function scoped variable here, we would get some different behavior. So if I change this to var, you're going to see that different behavior here. But just to wrap up here, you can see that in this scope, it logs out a different value compared to this outer scope here because these are in two different scopes. So let is specific to a curly braced block. All right. Now, if I change this to var, you're actually going to see here that a reassignment takes place. We're actually going to declare this some value here, and then we are going to reassign it here because we're using the same label name, because this is all technically within one function. Even though this doesn't look like it's in a function here, you can think of that in JavaScript, everything is always going to be running within some kind of global function. And then we can create inner functions within our programs. But if this file is just running, we can think of it running like within a global function. So these are all within the same function here. So this is actually going to take place as a reassignment. So if I run this here, you can see that it logs out the same values in both instances here, within the while loop and outside of it, because these are both in the same scope. So a reassignment takes place here. And generally, having block scope variables tends to be a little bit better, as it kind of hides your values a little bit more, and we run into less kind of accidental reassignments like we do here, and we run into kind of less bugs and less global name collisions. And a general principle within programming is to try to keep things kind of only keeping your values only accessible where they're actually needed to be accessible, as that can kind of prevent some of those bugs. All right. So let is block scoped here, and then it's also reassignable. So this is the same example I had earlier on reassignment. So I create this let value, or this let label, some value. I assign it to some value, the string some value. I console log it, and then I reassign it to new value, and then I console log that out. As we can see, we get two different values here because it hits this line. I haven't reassigned it yet. It will log that out. And then I hit this line after the reassignment takes place on line 19, and it will log out the new value because let variables can be reassigned. Now, it also does not hoist. So let me show you here. I tried to reference this declaration here on line 17 before I actually assign it to this value, and you're going to see I get an error. Now, this error is actually kind of interesting. Well, interesting to someone that nerds out on JavaScript, I guess. So it says cannot access some value before initialization, which that is telling you right there that when you hit this line, JavaScript knows that you have this variable, some value. It knows that this declaration exists, but in let declarations, it's not going to allow you to access it before you assign it to a value. But as we can see here, it knows that it exists. And you're referencing it before it exists, but with let, it's going to throw an error here. Now, const is very similar to let. So const is also block scoped. It does not hoist, so it does the same thing that let does, but it is not reassignable. Const stands for constant. This value cannot be reassigned. It has to remain a constant value within your program. But there's one kind of edge case, or one kind of tricky thing, not really an edge case, but a trickier thing with const that can be confusing. So first off, let me show you that it is indeed block scoped. So this is the same example as our let keyword. We have the outer const and the inner const. And in this example, if I run this, you're going to see that I do indeed get two separate values for the inner const and the outer const, because this block has a different scope than the outer block here because it's within these curly braces. And like I said, this is going to work for while loops, for loops, just an empty pair of curly braces. That's also valid. You can do all that. So const is also block scoped, and then it does not effectively hoist. So if I run this here, you're going to see I get cannot access some value before initialization. So same thing. It knows that const exists here, but it's not going to let you access it before you initialize it with a value or before you assign it to some value here. Now, the tricky thing with const. So it does not allow reassignment, but you can mutate non-primitive values because it's still assigned to a certain non-primitive value. So this is going to be an object, an array, something like that. It can still be assigned to that value, and you can still mutate that value as you wish, and you're not going to get any errors. So if you push an element onto an array, you're not changing what your label is assigned to. You are only changing a value within the array. Same thing with objects. If you change a property on the object, you're just changing a value within the object. You're not actually reassigning that const label to a different value. It's still assigned to the same value. That value is just holding different values within it. That can be a little bit tricky, and often when you're newer to const, you might think, how can he mutate that value there if it's not reassignable? Well, it's not reassignable to a new value, but if it's still pointing to the same value, the same object, you can mutate that object. So let me first show you here. If I create the const some value and assign it to a string some value, and I log that out, and then I try to reassign it here on line 26 to some new value, and I try to run this, you're going to see that I get an error. Assignment to constant variable. So you can see JavaScript hits this line, it logs it out. That's totally fine to do. But then it hits this line, it sees that I try to reassign this constant label here to a completely different value. So with a primitive value, like a string is, it's going to actually point to a completely different value here, and that is not allowed with a const declaration. And then I get this error that assignment to constant variable. That is not allowed. And just a note on technical communication, I kind of personally find it a little bit confusing to say a const variable, as I kind of feel like a variable implies that that value is changing. So I tend to just call it a constant declaration, but that's probably just some pedantic technical communication thing that I prefer, but it's people are going to understand what you're talking about if you say const variable. Like that's also a valid thing to do. As you can see, the error message even says that. All right. So here's my example of changing a non-primitive value. So I create this object here, some object with a name and YouTube channel property with the name has a value of Ryan and the YouTube channel property has a value of code James. And James is my middle name in case you were wondering. But here on line 27, I access the YouTube channel property here on this object, and then I reassign this property to code Ryan. So some object, this constant, is still pointing to the same object here. All I've done is mutated a property within the object. So since this is still pointing to the same object under the hood, if I log out some object here, you're going to see that that runs. And I get YouTube channel is now code Ryan for the YouTube channel property because I can reassign it here. Now, on this line here, line 29, if I try to, so let me delete that. If I uncomment this and I try to reassign some object to a totally different object here, so I'm initializing a new object by using these curly braces here. I'm trying to reassign some object to a new object rather than just mutating a property on an object. You'll see here when I run this, I get an error, assignment to constant variable. And you can see here on line 29, I'm trying to do that. All right, so with constants, if it's pointing to the same value, so some primitive value, an object or an array, you can mutate that object as long as you don't change the reassignment. But as soon as you go to reassign some object to some other value and some object is a constant, then you are going to get an error because you cannot reassign with constants. Okay. So hopefully that kind of clears up that kind of trickier part with const. But let me kind of give you a rule of thumb here with JavaScript variables. So a nice rule of thumb is defaulting to const. Now, why do we do that? Well, for one, it's block scoped instead of function scoped. And like I said earlier, block scoped allows us to kind of keep our values less accessible throughout our programs, which can prevent bugs. And then also with const, you can't reassign it to different values, which can help prevent bugs as well, as if you accidentally reassigned some label to a value and you kind of forgot that you did that, that's going to lead to bugs. And it would be better to kind of default to const and then, I need to reassign this value here. I need to use a different variable. All right. So when you do need to reassign a certain value, it's probably a good idea to use let instead of var for the same reasons. Let is block scoped, and that's going to keep your values in your program a little bit more private, a little bit less accessible kind of globally. So a good rule of thumb, defaulting to const, and then when you need to reassign some label in your program, then you can use let, which means that the use cases for var are probably very little. And in my professional career, we actually don't use var at all. We just use let and const, but you're still going to see var in legacy code for sure. And some teams might decide to use var in certain use cases. So like I said, this minimizes the mutable state within our program. It minimizes the state that is changing throughout our program. If we default to const and we try to reassign that const and start mutating this different state within our program, that can generally lead to a little bit more bugs. And it's kind of a good practice to minimize the accessible values throughout your program and minimize that mutable state. As I say here, the less things that are changing throughout your program and the less stuff you're kind of mutating and reassigning, the more predictable and the easier programs are going to be to reason about. So in summary here, var is function scoped, it's reassignable and hoisted to undefined. Let is block scoped, it is reassignable, and it doesn't effectively hoist. And then const is block scoped, it is not reassignable, which is different than just mutating a non-primitive value, and it also doesn't hoist. And a good rule of thumb is to default to const most of the time, and then if you need to reassign a certain variable in your program, then you can use let. So I hope you enjoyed this, and I will see you in the next one.